All right, what's up, guys? My name is Wesley, and welcome to the ASA YouTube channel. In today's video, we're going to be speaking with Reece Wilkinson, a PhD student from the University of Kent in the UK. And we're just going to talk to him a little bit about the trials and tribulations that he has faced thus far throughout his PhD program, and then also get his opinion on things like what you might want to pick as far as a major if you're going into an undergraduate degree, or things you might want to look out for if you're interested in going into a PhD program similar to his. So without further ado, let's get right into it.
I guess to start things off, I just want to ask you a little bit about kind of how undergraduate went for you, getting into undergraduate, going through it. Um, Tell me a little bit about your major and also at what point during undergrad you decided that you wanted to go into a PhD, were gaining interest in astrobiology.
My undergraduate was probably quite different from a lot of other people's. So I did mine through the Open University, which is a university based in the UK, which is all based on distance learning. So there are no in-person lectures or tutorials, or at least very few of them. And I did something called a combined STEM degree. So that allowed me to choose lots of different STEM disciplines without committing to one. And so because I didn't really know what I wanted to do at the time, so that allowed me time to experiment and try different things. So I did human biology, cell biology, more kind of traditional geology, astronomy, physics, planetary science, the whole kind of mixture, which turns out to be quite useful for astrobiology stuff. It's a very interdisciplinary field. But the thing that kind of triggered it to me that I wanted to go into this more as a career was during my second year when I did planetary science and astrobiology module. And just through the process of that, okay, yes, that's the combination that I'm looking for.
Okay.
And so I knew.
So the bell went off. That's when the light went off, is during that class, or
Yeah,
during that module rather. Okay. I think that's the experience that a lot of people have. Like, I know I had that experience as well, where I knew it was an interest of mine. I couldn't really put it into words until someone else gave me the word, and then it all just
yeah,
bam, it all clicked. So that is a really cool, shared experience, I guess, that many people seem to have.
yeah. Because before that, I didn't have a word for it. For some reason, I'd never come across it until I was looking around for my second year modules. Yeah, so my undergraduate year over here, so that was for 3 years. And then I knew at that point at the end that I wanted to go and do a master's. So I looked around and ended up doing, there aren't really that many dedicated, certainly not for astrobiology, but even just planetary science is usually what it falls under. There aren't many of them, at least over here. But I ended up going to do it at University College London,
Okay.
Masters in Planetary Science. So the way that that works is that it was half and half. So half of it was taught. So that was traditional kind of in-person lectures, coursework, exams, that kind of thing. And then the other half, which you mostly did kind of during the summer of the year, was a research project. And I knew going into it that there were supervisors available to do astrobiology projects. So that was part of the appeal of doing the course in the first place. The taught lectures were more based around, well, planetary science. So anything related to planetary science that included plasma physics, atmospheric dynamics, climate science. But my research project for the masters was looking at whether materials taken from Iceland from volcanic eruptions are analogous to Martian materials, in that the Icelandic materials may contain, having experienced the same conditions as those around Martian volcanoes, whether they contain organic materials or biomolecules that are relevant to life as we know it. And it turns out there are a few. And that was done using FTIR spectroscopy, which is analogous to the same equipment that will go on to the ExoMars rover when it eventually goes. So they were taken and then kept in a sealed bag for 8 years until I stumbled upon them. So yeah, I got to actually handle the material, kind of break it up, put it in the under the for the spectroscopy, and then put the data from it, learned how to interpret that data, which is not necessarily easy because it generates quite a lot of peaks And I mean, there's a lot of data out there and from previous work about what those peaks are and whether it's a significant peak or not. I enjoyed the experience of it. I enjoyed the experience of doing the research. I mean, it was in some sense quite a simple project in that it relied only on kind of one analytical technique. But yeah, I really enjoyed doing it, and I knew I wanted to do a PhD at that point. But I knew I wanted to do a PhD in something that actually involved biology. So working with bacteria, working in microbiology, because I had quite a big interest in extremophiles.
Would you say that getting that generalized undergraduate kind of helped you mentally prepare for the master's? Like, do you think that having that breadth allowed you to feel a little more confident going into that master's?
Yeah, I think so. I think if I'd just done, kind of the vast majority biology, but yet knew at the end of it I wanted to do something which was, the vast majority of the master's was geology, I think I would have struggled a lot more. Yeah.
Okay. And so if you had to, I guess, give one piece of advice to someone who is a high schooler, maybe looking to go into college, who had the option to major in something and minor in another, so they can really only choose between two subjects, what would your advice be to someone like that?
I think the focus traditionally, I mean, most people come into the field usually from a geology background.
Mm-hmm.
So I would probably start with that and incorporate biology into that, or biology, biochemistry, something of that around that route. Maybe it doesn't necessarily have to be, kind of hardcore microbiology, because I mean, we don't have a lot to go on with that at the moment.
Yeah.
Apart from looking at things like extreme environments on Earth. So things like, geochemistry, chemistry, understanding of organics.
I think that's good. I think you've pretty much, I agree with you. Like, I think you've hit the nail on the head there. That was something because it was something I ran into sort of halfway through my degree. I realized, I'm majoring in molecular biology, but I'm sort of missing this very necessary education when it comes to physical science in a geological or planetary focus. And so I decided to add my minor in geology, but there's definitely a part of me that wish I had known that at the beginning, because I might have done it flip-flops going in. I might have majored in geology and minored in bio, sort of like what you're saying. So I think a combination of those two in either way is probably good, as long as you can get that combination. All right, so you've gone through your undergrad and your master's at this point, and you've decided that you do want to go into a PhD. Tell me a little bit about what that process looked like for you. Was it, the initial decision, was it overwhelming? Did you feel like there were too many options, not enough options when you were looking at applying to different institutions? And then also tell me a little bit about what your application experience was.
I have to say at the time, I wasn't completely convinced that a PhD was right, but it seemed like the most logical thing to do for me. I couldn't imagine myself doing anything else.
Sure.
In terms of the availability of projects, I applied to quite a few, not just in the UK. I applied to some kind of in Europe as well. I think I applied to about 12 in the end. So they were a mixture, but the focus was largely on either, again, because I wanted the microbiology experience, so I focused a lot on those applications. But the other ones were, again, kind of geology, geochemistry, organics stuff. So things looking like trying to look at the total kind of organic record for early Earth projects involving extremophiles, so going out and doing field work to take samples from extreme environments and seeing what the limit of life is and whether that's applicable to different places that we know of. So yeah, there's a good amount if you look, and I think there are more coming as more places kind of invest kind of funding and time into astrobiology work as the field grows and people become a bit more aware of it. Because I mean, at the time I wasn't aware of it, kind of 6 or 7 years ago when I was doing my undergraduate. I also for pretty much all the applications, I would completely pick apart the project description and identify some questions and then get in touch with the supervisors, who almost all responded and were quite happy to answer the questions, just so that it helps you as well to know whether that project is really for you, based on if you're able to pick it apart, understand it, what questions you have, the answers you get back. I found that quite useful because it helped me rule out a few that were maybe a bit too geology based that didn't quite match my interest.
Sure.
Like there was some looking at things like organics in sediment, but it was more to do with the physics involved and the sticking of sediment to the organics, which I thought that probably didn't really match my background or kind of skill set. Maybe 3 decent questions. I mean, you can't really have 10. I think that might be a bit much. But I think something like that, like 3 or 4 questions that shows that you have a understanding of the project, but also just want a bit more information. Like most of the questions that I ended up asking were more about the actual methods and the practicalities of doing the project.
Okay.
Because a lot of the project descriptions wouldn't give a huge amount of detail of the actual analytical methods. So, and sometimes they would send things like kind of background papers from stuff that had been done before with the same lab that was similar to read. So, and that was useful too. The vast majority of the interviews that I had were really standard, like 20 to 30-minute interviews. I had a few in person because I was applying, we're talking January, February 2020 here. So I had a few in person that I would have to travel to. Then that very abruptly stopped, obviously. And so they ended up being mostly online. After that. But they had the same format essentially either way. It was the same, just a 20-30 minute interview, so it doesn't really make a huge amount of difference. You can argue that you maybe miss out on the kind of small talk and chat maybe with the people who are interviewing you online as opposed to being in person. But yeah, I think I'm not sure what the policy is now. I'm going to assume that most of them are probably still online purely for convenience. I don't know.
Yeah. Okay. And so when you were doing the interviews, and I know it's been a while now, so if you can't recall, I understand. But sort of run me through what the conversation was like. Were they more interested in you as an individual and sort of what you would bring to the table, or were they more interested in your current knowledge base and how that's applicable to their project?
I would say that the focus was a lot more on you as a person.
Okay.
So what you can personally bring to that project, but which includes stuff like background knowledge. But you're not going to be. I wouldn't say I was heavily tested. You're not going to be asked to kind of just regurgitate information. It was more about kind of soft skills as opposed to hard skills, I guess.
Okay.
Again, yeah, I am struggling to remember a little bit now that you think about it.
No, that's good. I just want to mainly get confirmation and also highlight for the viewers that when you're interviewing for a PhD, a lot of times it's more of a holistic approach where they are very interested in you as an individual and sort of how you'll mesh into the environment, into the lab. Of course, they want to make sure that you know the right things, but they're going to place a certain degree of trust into your credentials for that. They're not going to slap down a quiz, at the beginning of the interview or anything. So your acceptance process, were you given multiple offers? Was that the only offer that you received from the one that you're at now? What did that look like for you?
I got 2 offers and it was a fairly easy decision in the end, because the one that I ended up choosing had that much stronger kind of biology experience that I wanted out of it, whereas the other one was more kind of geochemistry. So it was a fairly easy option.
How are you liking it there so far? How are you liking or what has your experience been like so far, I guess?
Well, that's interesting and complicated.
Okay.
Because it's kind of there have been a lot of kind of external factors that have affected not just me but everyone. I started September 2020, which is not a very good time to start things. So there were limitations on access to labs, which obviously slows you down quite a bit. And that continued on for the majority of the first year. And then we have issues with, what that does is creates a backlog of work for other people. So there are things that need to be done. You're essentially playing catch up kind of in the labs, at least in my experience. We carried on having issues so in my second year with things like supply chain issues, getting hold of bits that we needed would take, several months in some cases. Again, I don't know. I'm assuming this is a pretty much kind of universal experience, at least in the UK anyway.
Yeah, I would assume that it's pretty universal considering everything we've heard about supply chain issues and everything. I know that we had a lot of supply chain issues here in the US, so I can't speak from firsthand experience that those have been felt in labs, but yeah, like you, I would assume that has to be the case.
Yeah. I mean, kind of basic things, kind of basic lab consumables were okay because they're fairly easy to get hold of and quite cheap to make. But when we're having bits for example, in the physics workshop that have to be sent off and be machined, they have and sometimes have to be designed kind of in-house, and then the designs are sent off. That whole process ended up taking several months for things. It's only really now that we're getting back to something resembling kind of having everything that we need again. And then we have kind of issues with just short staffing within the university now, which slows things down because there aren't enough people to do things like process orders.
So your situation is a bit unique in the fact that there are always, well, I say always, most of the time there are unforeseen roadblocks and things that come up during someone's PhD, and their PhD or thesis rather, tends to evolve a little bit as time goes on. Do you feel like that has had a direct effect on your thesis, or do you think that it's not so much a direct effect, it's more so just change your approach, I guess?
It's made us think a bit more about alternative work that could be done. So yeah, in some sense, maybe the limitations means that kind of how they say, having limitations on things makes you more creative because you think of a way of getting around them. I mean, I would say that, well, the things that I've described there are more kind of external to the actual project itself. So, but I would say that, the actual project itself has not been kind of smooth sailing either. So the kind of working title for the project at the point of when I started it was do planetary impacts contribute to the evolutionary change? The main piece of kind of equipment that I use as part of the project is a light gas gun, which are, there are a few of them kind of around the world. I think there's about 3 or 4 in the UK. What they're used for is to simulate planetary impacts. So you can fire things depending on different guns and different configurations. The one that we have fires at a top speed of something like 7.5 kilometers a second. So the idea being that we would fire projectiles at targets that contain a bacterial sample. So what we use mostly is E. coli, just because it's a standard, model organism for biological research. And then we recover the sample, taking back to a microbiology lab and see what the effects have been on the survival rate. So looking at the pure numbers that survived, knowing the numbers that you started with in terms of viable cell counts, and then going a bit further and looking at any potential change in phenotype. So some of the things that we've tried to do are look at whether there's been a change in the metabolic rate of the population of cells. So using an oxygen electrode, and looking at possible kind of changes in the antibiotic resistance profile. So spreading some of the recovered cells onto agar plates, but with antibiotic discs on them that test for a range of different antibiotics and seeing if they still grow or not, if there's a change based on a control sample. So that's kind of the overall premise. The issue is that obviously the light gas gun is a very physics heavy workshop. That's essentially what it looks like. And setting things up in a way that you can put bacterial samples in there and have them come out being clean is not easy. The kind of basis for the project in the first place, the kind of background work, was that there have been previous experiments done in the same lab to look at the panspermia theory. So this was the idea of transferring, having bacteria inside a projectile, firing at a target and seeing just if anything survived. And the suggestion from the previous work is that things did survive, but with a very low survival rate. So what we wanted to do is get a better idea of the actual numbers, so properly quantifying that survival rate, as opposed to just really saying, look, growth, it survived. And then going beyond that and looking at evolution to see if, we're talking kind of, if you think kind of early Earth, late heavy bombardment time, whether that may have had an influence on the evolutionary pathway of organisms at the time. But the difficulty is mainly to do just with the materials, because again, doing it in a way that means that you can get a bacterial sample out cleanly and recover it, and that it's in a form that is versatile enough to be used for various microbiology techniques, is not easy. And that's been kind of the main focus, really. I don't think we really have anything that's conclusively worked so far.
Are you looking at sort of the survival rate of a physical impact, or is it more so the survival rate of like an airburst?
So it's physical impacts. So you have a solid projectile, usually made of nylon, that hits the target of your choosing. The airburst thing is interesting. I'm not sure you would achieve the same pressures, because what you have to think about with the impacts is the conditions that generates. So that could act as a selective pressure that drives forward the evolution. So you get, very, very high, mainly temperatures and pressures. So we're talking pressures on the scale of, tens of gigapascals, it depends on things like the materials that you use and how kind of resistant they are to the extreme pressures, the velocity. And then temperatures, potentially, I think, hundreds and thousands of Kelvin. But the thing about the impacts is that it's a very, very short time scale. So we're talking, sub microsecond in terms of the peaks, which you can compare kind of to things like, which is a weird avenue that I didn't think we'd go down, things like the food industry. So things like, pasteurization use, temperature, pressure to sterilize. But that happens on a much longer time scale, but with much weaker pressures, and seeing whether those two conditions are comparable. So whether it's not the magnitude of the pressure, but is actually the time exposure that is the critical factor in leading to a change in the survival rate and potential phenotype.
Nice. Yeah, that is very strange that it could lead you down the avenue of looking into the food industry. But I guess this is sort of the endless mystery box of problems that I seem to hear about often when speaking to people who are going through a PhD, and that is like, you end up going, well, not always, but a lot of times you'll end up going down a lot of avenues like yourself, and digging into different niches in science that you thought would not even be nearly applicable to what you're researching. So that is an interesting characteristic of a doctorate as well. So other than your, kind of what you're doing right now, working on your thesis and whatnot, how have you found the teaching side of things to be?
Yeah, I actually really like the teaching. I think it is useful. I think having to teach, it reminds you kind of almost the basics, the things that you definitely should know. And it's the saying, the best way to learn something is to teach it, I suppose. I mean, the way that the teaching works that I have, so a lot of PhDs here, well, I think less of them now than they used to be, would have a requirement that you did have to do a certain amount of teaching hours. I think that's possibly more of a thing in America than here now. there will be a certain amount of teaching hours that you have to do in return for your stipend or extra pay or whatever. But over here you can do it in the form of demonstrating. So you would help out, at least in the physical sciences side and biosciences side here. You would help out with giving lab sessions and then marking assignments and that kind of thing, which usually pays reasonably well, and you can take on as many hours of that as you want to, or sometimes it can be a requirement. But my teaching is not really like that. So I don't teach at the University of Kent. So I have a separate job as an associate lecturer for the Open University. So I've ended up, you met the planetary science and astrobiology module that I mentioned at the start.
Yes.
I now teach on that module.
Wow, that's cool.
So I think 6 years later, I've ended up
that's full circle if I've ever heard of it, for sure. Yeah, that's pretty awesome. So you're really enjoying that then, I assume.
I kind of, I don't know. I don't know quite what it is about it that makes me enjoy it more. I enjoy just seeing students progress, I guess. The Open University has a very different kind of demographic in terms of its students than other places. So most people are kind of in full-time work and will take on the degree part-time. Some of them won't have been in education for decades. So you have to deal with and help them along with that. So there can be quite a steep learning curve at the start. I teach on the planetary science module for second year, and I also teach on a first year more generic science module that focuses on practical science skills. So basically just around good practice designing an experiment, data handling, interpretation. As compared to, there's a kind of complementary one in the first year as well, which is more theory and knowledge based. But I think the skills thing is a bit more difficult to pick up, especially things like maths. That kind of scares quite a lot of people.
Yes, we all know about the maths, that's for sure.
Yeah. I do enjoy doing that. Again, that's all distance learning mostly. So I'll have the majority of the work is preparing and giving tutorials online. Although they are bringing back some of them in person, which I did a few weeks ago, which was for a day, which was a lot of fun because I'd never really taught students in person, and then I'm suddenly presented with a room of 60 students that I have to deal with for a day. But I think it went really well. I mean, I think it wasn't perfect because it was my first time, but it's something I'd do again. And then outside of that, it's marking mostly, and that's the main way of giving feedback to students, is through comments on the marking.
Okay.
All right, that's going to be it for today. I'm going to go ahead and leave Reece's email down in the description below in case you have any questions for him. But other than that, go ahead and like, subscribe, and I'll see you next time. Peace out, guys.